So this is the maintenance and safety lectures, which is lecture number 18. So let's take a look at why we need the maintenance, the requirement of maintenance. So the maintenance of automated system is typically refers to mechanical, plumbing, electrical repair of equipment. So these three types. So if you go for industry, you have to deal with the maintenance all three types, even if you're electrical engineer or technicians, mechatronics technician. So you have to deal with the mechanical part as well as the electrical part. So the electrical equipment could be the programmable logic controllers, industrial controls, communication links, and robotic systems. Most traditional approach is to fix it when it breaks, maintenance, which means like so you just wait for until something breaks, so then you go and fix it. So this results unexpected downtime of the production and at cost. Like if you're running a production line, so if something goes wrong and you are trying to fix it, so it will stop the production cycle and it will add a lot of cost to the company, right? So this is not the standard way. So there are some other ways of maintenance. So the fix it when it breaks was a most traditional approach. So if it is a small industry, it could be affordable, but in large scale, this is not a good practice. In that case, the preventive maintenance and predictive maintenance has been introduced, and these two techniques are designed to increase the reliability of the assistant, reduce the amount of reactivity to failures compared to the traditional fix it when it breaks approach. So most of the industries is as a method of maintaining using preventive and predictive techniques. So what is the preventive maintenance? Preventive maintenance is a proper preventive maintenance program should be conducted for smooth running of plant and to avoid sudden breakdown. So you means like you define regular time spans, like once in every month, you go and do some maintenance to each section, and you are just happy with like you do the maintenance and you will be sure like until the next maintenance, everything will be safe, right? So it is preventive maintenance. So typically used when the organization wants to decrease the unplanned downtime and emergency maintenance. So it will reduce this unplanned downtime. Like you just do the maintenance once in a month or once in 6 months. So you don't expect anything to break down between this period, and that will reduce the unplanned downtime. So the work orders are scheduled for inspections, so lubrication, filter replacement, and part replacement. So you do your maintenance and focusing on this section, so it will be all good. So these are the benefits of preventive maintenance. So it is proactive, which means acting in anticipation of future problems. So it's proactive and limits the unplanned downtime and increases the equipment lifespan. And it is efficient, especially when with experienced persons deal with. So these are the challenges when you implement preventive maintenance in any industry. So it may be addressing problems that does not exist, right? So you do the maintenance regardless of the identified issues, like no matter there's issue or not, you just do the maintenance. So you just change the lubricant and filters and everything. So it will add more cost, right? And it requires more intensive inventory management for replacement components. So every time you just go and replace component in the 6 months and expecting the new one will not fail within the next 6 months. And however, so you have to go with this maintenance in regular intervals. So it is increased planned downtime, right? Not the unplanned. Unplanned means like something breaks down and you have to fix it and it takes some time. But planned downtime is so for maintenance also, you have to shut down your production line and wait until the maintenance is done. So it's planned downtime increases. So if you do it every month, so that you have to stop the production line every month for this preventive maintenance. So it increases the planned downtime. Okay, right. When it comes to PLC, so any technicians or engineer has to deal with this checklist for the preventive maintenance of the PLC. It's a good practice. Make sure you remember these things, and you have to practice these things when you go for industry, right? So the good practice is to back up the PLC program, right? So you have to have an up-to-date copy of the PLC program, somewhere stored separately. So in the case of PLC becomes inoperative, like if the PLC damaged and it needs to be replaced, so your backup file can be just downloaded to the new PLC. Okay, so otherwise you will end up with like a massive problem. So anyways, if you do some updates or anything, just back up your code, store in a flash drive or somewhere in your computer. So you know if the system PLC down, you can just upload the new your previously stored program rather than like spending hours of re-implementing the whole system. And the next one is checking the power sources. So you have to see the operating voltages at the rated value, and the input supplies are free from spikes. If the LED indicator blinks, sometimes the battery needs to be replaced immediately to avoid any loss of data. So sometimes the PLC comes with battery backup. So if this indicator happens, so you have to replace the battery. It will prevent the loss of data. And you have to check the operating environment. So check the operating temperature, humidity, and other environment factors to satisfy operation of the PLC in the control cabinet. And dust cleaning and ventilation checking is again important. So regular cleaning is required to remove the disposal dust on PLC components. And the cooling vents must be remain clear, and air filters should be clean for proper ventilation. And unobstructed air supply ensure the heat dissipation of the electrical components. So you have to just go and regularly visit your PLC control cabinet and see that cooling fans are clear and there's no dust inside. And sometimes you when you go for the control cabinet, you accidentally just put this document on top of the PLC and just leave them on the control cabinet, right? That might be cause some issues, like if a fire happens or these papers could burn out if they're overheated, getting close to overheated devices, and it could do some damage. So just remove the unnecessary items. So if you read the document and if you just accidentally put into the PLC control cabinet, remove that and remove everything and just leave the what should be there. And the other thing is checking for connections and discoloration, which means you can check the power and communication cables, wires, modules, and check whether they are tightened properly and there's no loose connection. And sometimes due to overheating, discoloration could happen, like deviation of the color, and it may result burnt odor, like a scent that when you smell that scent when something is overheating, right? So each and every component needs to be checked for such symptoms. Make sure like once in every month you go there and just inspect your PLC control cabinet and see everything is working fine. Otherwise, like these technicians or electricians will call you if something false happens. So then you have to go and rectify the issue. But if you do the maintenance, you can pretty much sure like nothing will happen. And you can do the inspection for corrosions, corrosion of connection terminals, contactors, or internal PCB can occur, and it should be monitored. And program checking and necessary updates. So proper functioning of the program needs to be checked, and if any modification is incorporated, then it is very essential to ensure that the desired function of the intended task. So if you do any modifications to the PLC, make sure you have done it properly under the supervision of your engineers. And sometimes you need to check the inventory and replacement items, like sometimes input to output card of the PLC can fail, So rather waiting for 6 months or 3 months and importing them from overseas, you can't stop your production line, right? So there's an inventory of warehouse, right? So you keep additional I/O modules or input/output cards or PLC modules in ready. In such a situation, if something goes wrong, you can just go and replace them. Then you can again order them and keep additional backup as a backup. So if something goes wrong, you can use from your warehouse rather than importing from overseas. That will save you runtime or downtime. And analog modules needs to be calibrated at least every 6 months. So their parameters could change with the environmental effect and like so on. These capacitors and resistors inside the analog modules could can age with the time, so you have to calibrate them regularly. Now we are moving to the predictive maintenance. Predictive means you don't do any maintenance in specified time intervals. Rather than you just use some data. Like for example, now in the aircraft, if you have an aircraft engine, right? So you collect this data like aircraft engine data, like so you plot it and you can see that the data is if it is something wrong, like you can determine that this is the right point the engine should be replaced from your previous data. Okay, so you have to have some kind of data analysis, and rather than like just replacing this engine in every year or something, you can analyze your data and make a decision. Okay, now I got into this data, within next 3 months this engine has to be replaced, right? So it's like a predictive, like a data, it's like a data science. So you have to have a sophisticated system for implement the predictive maintenance. And there are some benefits and challenges. I let you to read this thing, and it is pretty understandable. And so it is more complex compared to the preventive maintenance. You need to have specific people who train for this analyzing the data, and you have to have some system to collect the data. But the advantages is sure it helps to run your system with shorter downtime, and so identify actual issues earlier than so they can be addressed pretty earlier. So that's the theory of predictive maintenance. And now we are moving to the safety and industrial automation. So when designing a machinery or automated process, one of the most important factors to consider is safety of personnel who will be using the equipment. So the safety of the people is more important than the equipment when it comes for real work. The secondary importance is the protection of the machinery itself. So, you know, human life can't be replaced, but anything physical like a machines can be replaced at any time. Only thing is you have to be worried about the cost, but the human life cannot be purchased at any cost, right? So if someone dead, so it's done. So you have to protect your people and have to implement a health and safety system to safeguard them. So because of the movement of machine components on surface, caustic substances and sharp edges all pose potential dangers to exposed persons. So these are the hazardous things in industry. So in that case, many standards and regulations has been established. So each country and region has its own standards for concerning safety. The RoHS or the restriction of hazard substances is one regulation. Right, so safety precautions are required to be observed and followed in order to prevent possible accident and hazard during the daily operation. So you have to educate your workers and ask them to follow the health and safety guidelines. So they can be divided into two types, the warnings and coercions. So warning is just to indicate that the incorrect handling may cause hazardous condition resulting in death or severe injury. But coercion implies it is resulting in moderate or minor personal injury. So these are the standard symbols like you might have seen, like this shows like just pay the attention when you're handling, and this makes like there's a hazard of electrical shock. There are plenty of ways of implementing safety in the industrial automation. One thing is having emergency stop buttons. So pressing this kind of push button, allowing the system to stop instantaneously. And the other way is having a physical guarding, like when you're having this kind of robotic system, you can guard them using a fence. A simple method is it's a very pretty cheap method, but it's very good. So it covers the other physical barrier in intercourse between the hazard and the operator. So the machine operates here, so the operator is sitting here. So there's a barrier with the fence. So most common approach is having a mesh gardening. It's often used for around machinery, allowing visibility into the machine. And hazard warning and signage are required on machinery whenever hazards such as pinch point or electrical hazard exists. So you have to keep displaying these symbols in your process. And the final way of implementing the safety is design mitigation. So you can design your system by itself, avoiding hazard situations. One example is like rounding corners or placing moving parts and actuators in locations not easily accessible to personnel, which means like when you're designing your automated system, you can deal with like this kind of moving parts and everything put into a place where it is not easily accessible for people. So this is a very low-cost solution, and good designer will take this into account. So any design engineer, it is not only the automated of like put in the PLC and get the automation done. It is always about the having some safety. So you have to think about the safety as well when you're designing automated system. Use of finger safe terminal blocks and rubber bumpers or pads are example of reduced exposure. So you can use this kind of methods to safeguard the people who operate these machines. And the last one is the lockout tagout. That is, so when you go for replacement of anything, so you put a lock and a tag, and that will prevent anyone, like you go and make like a maintenance of a motor and you just disconnect your main contactor, right? Main power. So someone just realized like the system is not running and he just come and just press that D or direct online start, and that will literally kill you because the person who is replacing the motor can expose to electrical shock. So you have to use this kind of lockout tagout, like you just off the DOL and just put a lock so no one can come and operate it until your work is done, right? So this video will show that kind of example. Let's take a look.
Lockout tagout is one of the most important safety concepts in the workplace. Lockout tagout is the procedure that we use to control hazardous energy during processes like maintenance and inspections. The world we live in is powered by all sorts of energy sources. This energy powers our work. But if this energy isn't controlled, it can be dangerous and even deadly. This becomes especially important during maintenance activities like inspections and repairs. The way to control hazardous energy is by using lockout-tagout procedures. In lockout-tagout, the lock physically isolates the source of energy to prevent any accidental activation. The tag provides important information. Lockout procedures have 4 basic parts. Number 1, identify hazardous energy sources. Number 2, de-energize these sources. Number 3, apply locks and tags to prevent unintentional startup during work. And number 4, test the system to make sure energy isolation was successful. This is sometimes referred to as tryout. Then conduct your maintenance work safely. Once the work is finished, make sure you get everyone and all equipment out. Then you may remove the locks and tags and re-energize the system. Control energy hazards to keep yourself and your coworkers safe. Remember, lockout, tagout, and tryout to control hazardous energy sources.
All right, so I will play another video which is about like general safety practices for workers. So that is again really helpful when you go for industry. So this is just pretty brief on so it's like a day-to-day work and how you should follow these health and safety procedures. So don't forget, like if you go for industry for training as well. So if they give you this safety goggles or safety boots and everything, so wear them accordingly and follow these health and safety instructions. So that will help you to return back as a one person as you came to the work, right? Rather than like losing your body parts, right? So follow these instructions and make sure you are working in a safe environment and make sure you are returning as the same person who came to the site. All right. I hope that animation has shown you the basic health and safety procedures when you go for industry. So don't wait for learn from mistakes. I mean, like if there's a near miss event happens, so just learn from it and try to avoid it. And don't wait, like life sometimes doesn't have chances, second chance. So therefore, always follow the health and safety guidelines so given by your company. And so it is pretty general things, and if you might have learned from your previous lectures as well. So that's the all about this lecture. So thank you for joining today.